Hey y'all, it's me, Miss B, and today we're talking about how to determine if vectors are equal, as well as adding, subtracting, and multiplying vectors. Okay, so if I have a vector that has the same magnitude and direction, then they are said to be equal or equivalent. So here I'm just going to draw some random vector, and so if I have this vector and I can put it anywhere on this graph and it's still the vector. But if I have this vector and it changes direction but is the same length, make that a little better. So if it changes direction but it's the same length, or if it is the same length or same direction but different length, or both, I have one going completely against the grain here, then those are not equal. Okay, so any of those in pink are not equal to the ones in blue. So let's talk about V and negative V. So this is our initial side and this is our terminal side for V. So the negative V is named QP because of that, because they switch initial and terminal sides. Now, these two, PQ and QP, have the same magnitude, but different direction. Therefore, they are not equal. Okay, so then let's go ahead and run through how to make these equal. Let's fix those bars. I have no way of doing them in Google, so we just have to draw them in ourselves. Okay, so let's go ahead and find the magnitude of AB. And what's PQ? Oh, PQ is down here. Ha! Okay, so AB, let's go ahead and find the magnitude by doing square root of x2 minus x1 squared plus y2 minus y1 squared. So we have the square root of 1 squared plus 3 squared, which is the square root of 10, which is equal, we can just leave that exact. Okay, and then we'll just go ahead, in order to find the direction, let's go ahead and find component form of this. So this is going to be 3 minus 2, 0 minus negative 3. So we get the point 1, 3 for that vector on that terminal point. So let's go ahead and draw that. It's not right. Okay, so there's my terminal point, terminal side, initial point. Draw a little triangle. This is 3 and 1. And so then tangent of theta is equal to 3 over 1. To find theta, we do the inverse tangent of 3, which is 71.6 degrees. Okay, so let's leave that. And then I want you to pause and go ahead and find the magnitude and direction of PQ on your own. Okay, so for this, you should have had magnitude of PQ is equal to square root of 8 minus 5 squared plus 0 minus, I'm sorry, not 0 minus 3, 2 minus 1 squared. I did mix my x and y's up, but that's okay because we're just adding them. So we have square root of 3 squared plus 1 squared is the square root of 10. We're good there, so let's keep going. If I were to write out what PQ is, I do have that this is, what would that be? 2 minus 1, 8 minus 5, which is equal to 1, 3. Okay, so then we'll say tangent. If we were to draw a picture, we'd have this what am I thinking here? So 1, 3 would look like this. Let me kind of restart here. So if I were to draw it, this would be 1, this would be 3. And so then we're looking for tangent of theta is equal to 3 over 1. So then theta is equal to inverse tangent of 3 over 1, which is 71.6 degrees. Okay, because those two things match up, we have that P, yes, they are equivalent because they have the same magnitude and direction. All right, let's move on to adding and subtracting vectors. So it's pretty easy. We just add our x values together and our y values together. So there's the formula right there, but we're going to go ahead and jump into our first example. So to find u plus v, this is my u1, u2, that looks like an n, u2, v1, v2. So I'm going to go ahead and write this out as 4 plus negative 2, 2 plus 9, which then gives me that this is equal to 11, which is u plus v. Okay. For subtraction, same thing. Go ahead and try that on your own. All right, so we have u minus v is equal to 10 minus, 10 minus 2, 3 minus 6. So we get 8, negative 3 for that vector. All right, so we didn't graph the first one, but I'm going to go back and graph them. So let's go ahead and graph these two vectors. So first vector, u, we'll do v in blue, and then we'll do their combination in purple because that seems fitting. So you've got pink, blue, and let's change this to purple. Okay, so gonna go ahead and graph u first. So I've got 4, 2, there's that. Goodness gracious, that was not good. 4, 2. Then I've got negative 2, 9. Graphing that vector. And so then when we graph the purple, 2, 11, you can kind of see that it does shoot through. Gosh, that's not quite straight. Shoot through the middle there, and as a combination of both the blue and the pink. All right, let's see what u minus v looks like. So we've got u in pink again, V in blue, and we'll do U minus V in purple. So we've got 10-3 in pink. There we go. Then in blue we have 2-6. And then in purple we have 8-3. There's that vector. So that one kind of shoots off in a different direction. It's not between here, it's off to the side, but that is because of that subtraction there. Okay, so kind of a neat visualization there. All right, and then let's talk about multiplying by a scalar, and we're done for today. So to multiply by a scalar, all we're doing is multiplying the components by a scalar. Remember, the components are just our, like if we have u equals u1, u2, then the components are u1 and u2. All right, so let's go ahead and find 3u. And the way we do that is we're going to take 3 times this here. Actually, you know what? I don't want to write it that way. I'm going to do 3u equals, and then that's going to be equal to 3 times my first term component, then 3 times my second component, and then we simplify, so we get -6, 9. Okay, so all that does is stretches it out. All right, let's do this next one. So I'm gonna go ahead and let you do these next two on your own. All right, so for this next part, you're combining both multiplication and the subtraction. So we're gonna do 5u minus 3v, and I am gonna show all of my work. So I'm gonna have 5, oh my goodness. So 5 times 1 and 5 times -3 minus v, which is 2, 4. So we've got 3 times 2 and 3 times 4. So then we have 5 -15 minus 6, 12. And so then when we combine those together, we have 5 minus 6, -15 minus 12, finishing it out to be -1, -27 for that. All right, then this next one here, we've got 2u plus w. So change up my color here. So I'm gonna have 2u plus w is gonna be 2 times 1 times 2 times -3 plus w, which is -4, 1. So we have 2, -6 plus -4, 1. Then 2 plus -4, -6 plus 1, which is finally -2, -5. Now you don't need to show nearly as much work as I did, but I'm just showing work so that you guys can follow along a little bit.